Okay, students, now I will talk about question number 6, which talks about cannonball. It's shot at 80 angle above the horizontal with velocity 175 meters per second from a very high building. Okay, from a very high building. Its angle from here is 80 degrees with this speed. What are the components of the initial velocity? Okay, need to use this formula sheet always. Okay, this is our trajectory. We have point 1, point 2, point 3, point 4. This is the initial velocity, which is 175. This is the initial angle. Okay, if we need to find Vx at this point 1, Vx1 is equal to V naught, which is V initial, multiplied by cosine theta. Theta is 80. Vy1 is equal to V naught sine 80. In this case, we will find that Vx at point 1 is equal to 30.39 meters per second, and Vy1 is equal to 172.34 meters per second. Vx will be constant all over the way, but Vy will be reduced till this point. The velocity, the vertical velocity at point number 2 is 0, but the velocity at the horizontal velocity will stay the same. Okay, part B, how long it take to reach its maximum height, how much the time. Okay, I need to compute the time going up to reach the point number 2. I know that the velocity, the vertical velocity at point number 2 is 0 here. Okay, the acceleration is g, which is negative 9.8 meter per squared second. Okay, I will use this equation. Vy2 is equal to Vy1 plus g multiplied by t. I need to know t. Vy2 is equal to 0. Vy1 I compute it, which is 172.34 meters per second. Okay, I put all these variables in my equation. 0 is equal to V1 negative 9.8 multiplied by time going up. I can move this term to left hand side of my equation, then divide over g both sides. Then I can find t going up is equal to 17.6 seconds. The time from here to here, 17.6 seconds. Okay, now for part C, I need, this is part C, yes. After 20 seconds, what is the total displacement? From here to here, I need 17.6, yes, seconds. But the question asked me for about 20 seconds. So the body will come this track through this to reach this point. I need the displacement d. If I need to find d, then I need to find x at 20 and y altitude at 20. Okay, the time is 20 seconds, but the time at point number 2 is 17.6 seconds. So I need to find the displacement, this one, after 2.4 seconds after y max. At this y max 17.6, after 2.4 it is 20. Okay, at first I need to find y max. the highest altitude. y2 is equal to my y max, which is equal to y1 plus v at y at point 1 multiplied by the time going up. I find it, which is 17.6 plus half g time squared, time going up. Okay, in this case this term is 0. v y1 I know it, the time going up I know it, I calculate it now, plus half minus 9.8, which is g, multiplied by the time squared. Okay, then I can find y max, which is equal to 1515.36 meters, the highest altitude. Okay, now we can find that this is y2 or y max. I need y20. y20 is y2 minus this y, or I can find that also y20. I can use this equation. y20 is equal y2 plus v2, v at 2, multiplied by the time from point 2 to point 20 to go to this way, plus half g t squared. T squared and t, which are 2.4 seconds, which are 2.4 seconds after 17.6, which give us 20 seconds. Okay, so I use it. Okay, y20 is equal to y2. y2 is 1515.36 plus v at point 2 is equal to 0. So this term is 0, plus half minus multiplied by g, which is minus 9.8, multiplied by the time squared, which is 2.4 squared, 2.4 after the maximum point. This will give me 1497.14 meters. So the y altitude at time equal 20 is 1497.14 meters. Okay, now I need to find the x range from the point 1 to point t20. Okay, I have, or we have, constant velocity, which is 30.39. We computed before, and the time is 20. So the x range, this x value, is equal to 607.8 meters, and I compute y, which is 1497.14 meters. Okay, using Pythagorean theorem, the displacement at 20 is equal to x at 20 plus squared plus y at 20 squared. I put the values. I can find d20 is equal to 1615.8 meters. Okay, now if I need to find the direction phi, this is phi, I can find it because phi is equal to tan inverse y over x at that point, and phi in this case is 67.9 degrees. Is that clear? Okay, now for the next part, which is the how long, yes, does it take for the vertical velocity to reach 172.3. Okay, at first, if you remember that Vy at point 1 is equal to 172.34 meters per second. I need to find Vy at point to be 100. the same this point, but in negative value 172.3 just meters per second. It is the same value like this one. Neglect 4, we can approximate it to be in this range. So we know that from before, if we have the positive y in vertical velocity, initial velocity, we can find that the velocity at the same altitude will be the same. So the velocity at this point is equal to the same velocity at this point, but in the opposite direction, and so on. The velocity at point number 2 is equal to 0 upward and 0 downward. So I can use this equation, V final is equal to V initial plus G multiplied by T. T is the time going down. I can compute it, which is the same time from point 1 to point 2. We can find it in this way. V2 at point number 2, V3 at the point what we are looking for. We need the velocity to be negative 172.3 is equal to V at 2 is 0 plus G, which is negative 9.8 multiplied by the time. We are looking for the time after point number 2. We divide over G both sides, and we can find that the time is 17.6 seconds, which is the same the time from point 1 to point 2. Climbing up time is the same to the going down time. So the total time to pass this range is T going up plus T going down, which is equal to flying time from point 1 to point 2 to point 3, which is equal to 35.2 seconds. That flying time. Okay, for the next part, we need to find the range from point 1 to point 3. We know all the time. The time is 35.2 seconds, and the velocity in x direction is constant. We find it before, which is 30.39. Multiply it by the flying time this time. This will give us the value. The range is 1069.728 meters. So this range is this value. Okay, see you in the next question.